Welcome to Triomeet. Exercise question 2.23. Question here is, the sun is a hot plasma with its inner core at a temperature exceeding 10 power 7 K and its outer surface at a temperature of about 6000 Kelvin. At these high temperatures, no substance remains in a solid or liquid phase. In what range do you expect the mass density of the sun to be? In the range of densities of solids and liquids or gases. Check if your guess is correct from the following data. Mass of the sun, given the mass of sun is equal to 2.0 into 10 power 30 kg. And radius of the sun is given as 7 into 10 power 8 meters. Our question is to find the density. Okay, so how do you calculate the density of the sun? Density of sun is equal to mass by volume. Mass, we can write it as m. Sun is in the form of a sphere, so its volume will be equal to 4 by 3 pi r cube. So we know mass as 2.0 into 10 power 30 divided by 4 by 3 into 3.14 into 7 into 10 power 8 the whole cube. This will give us the answer 1.392 into 10 power 3 kg per meter cube. But according to significant figures, since this has only two significant figures, our final answer will be 1.4 into 10 power 3 kg per meter cube. This is our final answer. Also, this value, this range is in the order of solids and liquids and not in the order of gases. According to question, solid, liquid or gases. So this is in the order of solid or liquid and not gases. Let's solve 2.24 from units and measurements. Let's read the question. When the planet Jupiter is at a distance of 824.7 million kilometers from the Earth, its angular diameter is measured to be 35.72 seconds of arc. Calculate the diameter of the Jupiter. So when we're drawing this, suppose this is the Earth, this is Jupiter. What we require to find is the diameter. Calculate the diameter of Jupiter. So this is our question. This is equal to B equal to question mark. So from the Earth, the angular diameter has been given to be 35.72 seconds. The distance from Earth to Jupiter has been given to be 800, and so we've got D equal to 824.7 million kilometer. That would be 10 power 6 kilometer. Right? So from the parallax formula, we know that D is equal to B by theta. So B is the diameter of the Jupiter, theta is the angular diameter, D is the distance between the Earth and the Jupiter. In this question, we have to find out what B is equal to. Now, we've got our theta to be equal to 35.72 seconds. But we need this to be in radians. How do we do that? From example 2.1, we know how to convert 1 second to radians. Otherwise, it's basically just 1 second is equal to 1 by 60 into 1 by 60 into pi by 180, and this will give you radians. In solved form, it is 4.85 into 10 power minus 6. Do visit this video to understand how to solve it. So this would be 35.72 into 1 by 3600 into pi by 180 radians. So substituting all the values into this equation, we need to find what B is. B is equal to D into theta. D, we found the value to be in the question. In the question, the value is 824.7 into 10 power 6. Theta will be equal to 35.72 into 1 by 3600 into pi by 180. So this will give us the answer 1.429 into 10 power 5 kilometer. So this is the diameter of Jupiter.